So we're going to continue our discussion on solving trigonometric equations. This will be the last part of this section. In this part, we're going to look specifically at problems that are quadratic in nature, which remember means that your equations will have a squared in them. All right, so before we really talk about how to solve this, I want to review the algebra with you just really quickly. So remember that we have said that the sine is really just a function, just like the x is in an algebra equation. So if I was looking at this equation, 2 sine squared, I could say that this is the same thing as 2x squared, just sort of substituting in an x for that sine. And then minus 5 sine minus 5x, and then plus 3. So this is sort of the trig version of this, which is the algebra. So remember how we solved the algebra. We would look at first a GCF if there is one, which in this case there's not, but if there's something that you could pull to the front, that usually makes things easier. If there's not a GCF, then our next best bet in factoring would be to try to set up a double set of parentheses and fill in those numbers so that it multiplies out to be that quadratic. Okay, so just a quick review on how this works. So we would need whatever goes here and here would need to multiply together to give me 2x squared. So that part is fairly easy because the only way to make 2 is 1 times 2. And the only way to make x squared is x and x. All right, also remember that the things that you put in the back two positions need to multiply together to give you that positive 3. And so it's going to need to be either 1 and 3 or 3 and 1. And I don't really know which way it goes until I plug it in and try. So I'm going to go ahead and just put 3 and 1 in. And then I'm going to do a little checking. So I know that if it's going to be a positive 3, that either I need both of these numbers to be positive, because positive 3 times positive 1 is positive 3. But the problem with that is I'm never going to get a negative 5x out of a problem that doesn't have any negatives in it. All right, so I am actually thinking that I'm going to need 2 negatives. Okay, because I know that negative 3 and negative 1 multiplied together also gives me positive 3. All right, so once I get this thing factored, and depending on your skills in factoring, I would advise that you check it if you're not great with factoring to be sure that you have it set up correctly. Remember that to check it, you do the FOIL method. So we would do first times first. That would give me 2x squared. Then I would do the outside. So that would give me negative 2x. Then I would do the inside. That gives me negative 3x. And then finally, I would do the last. Negative 3 times negative 1 gives me positive 3. I would then combine my middle terms. So 2x squared minus 5x plus 3, and I would check it against the original problem to make sure that I've got things set up correctly. All right, so still kind of thinking about the algebra. Once I get this thing factored, remember that you're setting each term equal to 0, and then you are solving. So we would say 2x minus 3 is equal to 0. X minus 1 is equal to 0. We would solve each linear equation. and we would be done with our two solutions. Now again, I'm going through that rather quickly because that is the algebra and it is a review, all right, but I just wanted you to kind of remember that's the approach that we're going to take with the quadratic equations. So now I'm going to erase that and we're going to go back and do this with the trig function. So instead of the x's, we're going to do it with the sine functions. All right, so again, I would try to factor this thing into double sets of parentheses. We've already talked about how to factor this one. So I'm going to go ahead and just do the same thing. Remember that when we factored this with the algebra, the factors were, just going to jot down what we got just a minute ago. All right, so now I'm going to have 2 sine theta minus 3 and sine theta minus 1. So all I'm doing is putting the signs back in place of the x's. All right, so once we have that factored, then we're going to, again, set each one equal to 0. And we're going to solve for the function. So instead of solving for x like we did just a minute ago, we'll solve for sine. So I'm going to add 3 to both sides. So 2 sine theta is equal to 3. And then I'm going to divide both sides by 2. So sine theta is equal to 3/2. For the other one, I'm going to add 1 to both sides. So I have sine theta is equal to 1. Now, I know that in terms of memorized values, that I don't have a memorized value for 3/2 or for 1. So my guess is that both of those are going to need to come off the graph. So I'm going to very quickly sketch a sine graph. Remember that you should be able to do this quickly, okay? You don't need to do anything that's going to take you longer than about 30 seconds to get it graphed. Okay, and I'm going to look for places where the graph is first equal to 3/2. All right, well, obviously this doesn't exist because the highest point on the sine graph is 1, and we know that. So there is no place where sine is equal to 3/2. All right, so this one is kind of a no solution. All right, that is not possible. All right, now let's look at the other one. Where is sine equal to 1? So sine is equal to 1 at, here's the 1 point right there, and that angle, that's the first tick mark, so it's my first key point, it's at pi/2. So the only solution to this particular problem is going to be occurring at pi/2. Okay, so again, we're going to factor it just like we would factor in an algebra class, set each of them equal to 0, and then work at solving each of the linear expressions. All right, now for the rest of this presentation, we're just going to run through a few more examples. All right, so the one thing that I want to point out to you in this particular problem that we just worked is notice that all of your functions are sines. So that's the equivalent of having, like we said, x's throughout the problem. All right, this one has an issue because not only do we have a sine, but we also have a cosine. So that would be in algebra like me having a problem where I have 2x squared is equal to 3 and then a different variable plus 3. And that is not something that I can factor very easily. All right, so we need this thing to have the same function. So they either need to be both sines or both cosines. All right, so that's going to be my first issue here is I need to get this in terms of a consistent function. All right, so in order to do that, we have an identity that we learned in the last chapter that relates sines and cosines. So what I'm going to do with this identity is I'm going to come in and I'm going to, because I have a sine squared right here, I'm going to take this identity and solve it for sine squared. Okay, so I want sine squared by itself on one side of the equation. So I'm going to need to subtract cosine squared from both sides. So that's going to tell me that sine squared theta is the same thing as 1 minus cosine squared theta. All right, so I'm just going to take that identity and rearrange it. And now I'm going to plug in this in place of that sine squared. All right, so I'm going to rewrite my problem. So I have the 2. I'm going to substitute in the 1 minus cosine squared. And then on the other side, I have 3 cosine theta plus 3. So now I've fixed the problem of having 2 different functions. So now the entire problem is in terms of cosine. All right, so let's get it ready to factor. So what I need to do is get everything on one side. So the first thing I'm going to do is distribute this 2 across that parenthesis. So 2 times 1 is 2, and then 2 times cosine squared. Okay, I want everything on one side. I think I want to move these 2 terms to the right because I would prefer to factor with a positive number in front of the cosine squared. All right, so the first thing I'm going to do with that in mind is I'm going to subtract off this 2. Remember that you've got to do it to both sides. So now I have negative 2 cosine squared theta equals 3 cosine theta plus 1. All right, and then the last thing I'm going to do with this is I'm going to add the 2 cosine squared to both sides. All right, so this is going to give me a 0 on the left, and I'm going to put things in order as I go. So 2 cosine squared theta plus 3 cosine plus 1. And now I have it set up so that I can factor. All right, so let's look at factoring it. Again, I don't see any GCF that I can pull to the front, so I'm thinking that the first thing I really need to do is to try to make it work with the double parenthesis. So my first 2 terms need to multiply together to give me 2 cosine squared. So that means that it's going to have to be 2 and a 1. 2 times 1 is 2. And they both need a cosine. And then for the other 2, they need to combine to give me a positive 1. So that has to be 1 and 1. And if you note in the problem here, there are no negatives. So there should not be any negatives in your factored form either. All right, so once we get it factored, and again, you should check it if you have any concerns about whether you have factored it correctly, because if you didn't factor correctly, then you're not going to come up with the right answers. All right, so then I'm going to take each of those terms and set them equal to 0. All right, we'll solve each one for cosine. So to begin on this first one, I'm going to subtract the 1 from both sides. So I have 2 cosine theta is equal to -1. Then I divide both sides by 2. So I'm going to be looking for places where cosine is equal to -1/2. All right, so let's think about that real quick. We're still operating, and I didn't type this at the top of the slide, but we're still operating between 0 and 2 pi. So I know that I should have an answer. Let me think about my cosine chart. I should have an answer in the second quadrant and the third quadrant. I know that in the first quadrant, the cosine is equal to 1/2 at pi over 3. So there's my pi over 3. We need to send it to the second quadrant. So that angle is 2 pi over 3. And we also need to send it down. And that is 4 pi over 3. So those are 2 of the solutions. All right, and then we're going to solve the other one by subtracting 1 from both sides. So this is going to look, we're looking for places where cosine is equal to -1. And again, I'm thinking to myself, I don't know anything off the top of my head, so I'm going to try to pull it from the graph. So I'm going to very quickly graph a cosine graph. I'm looking for the place where it's equal to -1, which is down here. That is at my third tick mark. So remember, it goes 0, pi over 2, and this one is at pi. So that is also going to be a solution to this problem. All right, so 3 answers here. We're going to have pi, 2 pi over 3, and 4 pi over 3. All right, so that shows you an example where you did not have the same function to begin with, and you used an identity to adjust. All right, let's look at this one. All right, 2 sine squared theta plus sine theta is equal to 0. So on this one, notice that you don't have the normal setup of 3 terms, the ax squared plus bx plus c. You're missing that final number that usually sits there. So that's an indication to me that I probably can work it with a GCF. So I notice that both of these have a sine in common. So I'm going to factor that sine to the front. So I'm going to ask myself, if I look at this term and I take a sine out, it's going to leave me a 2 and it's going to leave me another sine because there was 2 of them to begin with. And if I look at this term and take a sine out, it's just going to leave me a 1. Now we're going to set each term equal to 0. So we have sine theta is equal to 0. That's the first term. And then 2 sine theta plus 1 is equal to 0. That'll be the second one. On this first one, I'm going to need the graph because I don't have a memorized value to know where sine is equal to 0. So I know that my sine graph does like this. I have a 0 here and here. I also have one here. That's going to be at the 2 pi. Remember first, third, and fifth. All right, so I have answers at 0 and at pi. Now, it's worth saying that I don't have an answer at 2 pi, because remember that 2 pi is the same thing as 0. And if I had written this restriction up here that you're going to see in your homework, it tells you to pull angles that are greater than or equal to 0 and less than 2 pi. But it doesn't include 2 pi again because that's just a repeat of the 0. All right, so these are two solutions to this problem. And then over here, I'm going to solve for sine. So I'll subtract 1 from both sides. And divide both sides by 2. So I need places where sine is equal to -1/2. That is going to be in quadrant 3 and quadrant 4. So I know in quadrant 1 it's pi over 6, where sine is equal to 1/2. So for quadrant 4, that's going to be 11 pi over 6. And for quadrant 3, that's going to be 7 pi over 6. And if you're not recognizing those angles, count them out. Draw them and count them out like we've done in class so that you can identify which angles you've got. All right, so there are 4 solutions to this one: 0, pi, 11 pi over 6, and 7 pi over 6. Okay, so let's look at this one. Cosine theta is equal to -sine (theta). So this one is a little different in that we don't have a squared term here. Okay, but I did want to show you this because it is something that you might see when you get to your homework. All right, so the first thing that I want to remind you of is that when you have a negative on the angle inside the sine function, remember that sine is an odd function, which means that that negative can come to the front of the function. So we already have one negative there, and now we're going to pull another negative to the front. So those two negatives are going to become positive. So we're really looking for places where cosine and sine have the same values. So this requires a little bit of thought on your part as far as your memorized values and trying to think about where sine and cosine are equal. Okay, I know it's not at like pi over 6 because sine pi over 6 is not the same as cosine pi over 6. But what about pi over 4? I know that sine pi over 4 is square root of 2 over 2, and cosine pi over 4 is also square root of 2 over 2. So I know that that's one of my answers, pi over 4. Okay, so let's think about another place where they are the same. All right. So I know that they're the same here. Let's think about this quadrant. So that's 3 pi over 4. Now, they both have the same value there, but remember that we have to consider the signs. Okay. So for the sine function, remember that the chart goes like this. And for the cosine function, the chart goes like this. So even though in that second quadrant they have the same value, one of them's positive and one of them's negative. So that's not going to work for me. But down here, they're both negative. So this is 5 pi over 4. So in that quadrant, they would have the same value and they would both be negative. And then in this quadrant, this is your 7 pi over 4. One's positive, one's negative, so that's not going to work. So we just have these two solutions. All right, and then I'm going to show you one more problem. I'm just trying to hit the different types of problems that you might see in homework. All right, so cosecant squared is equal to cotangent plus 1. All right, this is very similar to the sine cosine one that we looked at a minute ago. We would need an identity to substitute in so that we can either write it entirely in terms of cosecant or entirely in terms of cotangent. All right, so you have an identity which looks like this. 1 plus cotangent squared is equal to cosecant squared. That's one of your Pythagorean identities. So what I'm going to do is I'm going to take this right here and I'm going to substitute in this. So that is going in for cosecant squared. All right, so my problem now becomes, all right, I'm going to do that substitution. All right, and then I'm going to work at solving this. So the first thing I'm going to do is I'm going to subtract 1 from both sides of this expression. And when I do that, it just kind of goes away. And so it's going to leave me cotangent squared is equal to cotangent. All right, now I know that if I'm going to factor, I need them both on the same side. So I'm going to go ahead and subtract this cotangent off or move it to the left. So now I have cotangent squared theta minus cotangent theta is equal to 0. All right, and so we can go in and we can attempt to factor this. All right, so keeping in mind that you have a GCF that you could pull to the front. All right, so we want to ask ourselves, what can we pull out to the front of this expression and factor it out of both? All right, so I know that I can pull out a cotangent theta. Okay, so I've got it factored, and I can do a quick check. Cotangent times cotangent would be cotangent squared. Cotangent times -1 would be negative cotangent. And then remember, you're going to set each of these equal to 0 and work at solving. All right, so the first one is already solved. We'll look at that in just a second. The second one, I'm going to add 1 to both sides. So we're going to be looking for places where cotangent is equal to 1. All right, so I do know that part fairly easily because I know that cotangent is equal to 1 at pi over 4. All right, and it is a positive 1, so that's a memorized value for me. And I also know, let me check my sine chart real quick. So I have the first quadrant answer. I also know that there should be a third quadrant answer. So if you count around, all right, so there's pi over 4. If we move it into the third quadrant, that is going to be 5 pi over 4. So that will be a second solution coming off of cotangent equaling 1. All right, now I need to know where cotangent is equal to 0. And so that one is a little bit tougher because I don't have that as a memorized value. Okay, I don't know of a place as a memorized value where cotangent is equal to 0. And so I'm going to have to go back to my graph for my cotangent function and try to determine a place between 0 and 2 pi where that graph is equal to 0. And so there are actually two places. If you look back at your graph for cotangent, I'm going to try to sketch it real quick for you. Remember that you have an asymptote at pi. And also an asymptote at 2 pi. And then your graph sort of does this S shape in between. So right here you've got a 0. That's going to be pi over 2. And you're also going to have a 0 right here. And so that's going to be 3 pi over 2. So what you want to remember here is if it's a memorized value, you want to work from that angle. If it's not a memorized value, then you're going to need to work from the graph. Okay, so that should conclude that section for you. I know that that's kind of a lot, but again, I wanted to try to show you the different types of problems that you might see in the homework. But that should conclude that final section of 6.3 for us.